Hey guys, want to build a robot? If you're just starting off building robots, I feel like there are 4 foundational principles you've got to understand. If you're programming Arduino, that would be things like digital write, digital read, analog write, analog read. Once you have those 4 functions down, there is so much you can do with it. And I would also add to that list controlling DC motors using a motor driver and controlling servos. Once you have those 6 things down, you can add them together in so many different ways. Now, there are tons of awesome tutorials out there for controlling servos with Arduino. But today I wanted to focus on the differences between controlling servos with Arduino versus controlling servos with the ESP32. Now, this can seem a little intimidating at first, and there are a few key differences. But once you understand those differences, there's so much you can do with it. Let's take a look. So here we have an Arduino Nano and an ESP32. Now, I love this kind of Arduino Nano here. So this is the RF Nano. It has the NRF24L01 radio built in, which is awesome for creating wireless projects. Now, the ESP32 also has a ton of wireless communication built in, right? We have Bluetooth, BLE, we have Wi-Fi, of course. We even have ESP now. I love that stuff. So the Arduino has obviously been around for a lot longer. And so when you think of the number of projects and all of the amazing things that people have done with Arduino over the years, it's just extraordinary. You know, I think they deserve so much credit in helping shape this community of makers and young engineers. And there are Arduinos that have more PWM pins than the Uno or the Nano. You know, in this case, we're going to be talking about the Arduino Nano. You can totally use something like a 2560 if you wanted to, if you needed to use Arduino and you needed more PWM pins. But that being said, if you are using an Arduino Uno or an Arduino Nano in this case, you're stuck to 6 PWM pins. That's 3, 5, 6, 9, 10, and 11. So let's see, I don't think this model even labels them for you. Obviously they're labeled with a squiggly mark on an Uno. So we have pins D3, D5, D6, D9, D10, and D11. Now, one downside though is that the radio here uses SPI communication. And so the pins are actually hardwired 13 through 9. And so in reality, we actually just have 3, 5, 6, and that's pretty much it. And so if you only have 3 PWM pins and say you want to use some of them to drive a motor driver, you don't have as many options. And so if you need a lot of pins, you could totally use an I2C motor servo driver. Those are awesome if you really wanted to. But if you wanted to do this all in one chip, you may want to think about using an ESP32. So an ESP32 comes in a lot of different shapes and sizes. I love this model right here with the external antenna. I use these for all of our crazy robots, and it's a ton of fun. And so obviously the ESP32 has way more GPIO pins. And so what's so cool is, with the exception of a few input-only pins, you can use almost any of these pins as a PWM pin for servo control. Now, the biggest difference, and I think this can trip people up sometimes, is that there are not specifically PWM pins, there are PWM channels. And so even though there are 30 plus GPIO pins on here, you can't use 30 different servos if you wanted to, but you can use 16. And so what you do is you set up your PWM channels and then you attach pins to that channel. And I know that can seem kind of confusing, but that's why I'm making this video. So I want to make sure that by the end of this video, this difference is really clear and you have no problems controlling either a servo with an Arduino Nano or an ESP32. Let's go ahead and take a look at the Arduino Nano. So to demonstrate how to program a servo using an Arduino, I thought I would bust out the ACBR Robotic Laser Cannon Kit. This kit is a ton of fun. We actually just finished a little bit of a redesign on this guy. We added the screw terminal here for the laser and a screw block terminal here for some external power. But this is a really simple example here of how we can take some joystick data and we can correlate that to servo position. Now, in order for us to get a better understanding of how this all works, let's go ahead and look at the code so we can break things down and talk about how to program servo control. So just like the ESP32, there are more than one way to program a servo using the Arduino. Some people like to get in there and actually control the PWM directly using the digital write microseconds command. But the most popular way by far is to use the servo library. Now, the servo library for Arduino has been around almost as long as Arduino has, and it is really, really useful for controlling servos. It makes it really, really straightforward. And so the first thing we need to do is to add the servo library. So the servo library is built in whenever you download Arduino. So oftentimes whenever you're using a crazier library, you have to download it and install it. This is pre-installed in Arduino, so you don't have to add any other files. All you have to do is call it. Okay, so then we need to name our servo. We're going to be super boring here and call it servo 1. All right, now we need to attach our servo to a pin. In this case, we're going to start with pin 3. So we're going to start with the name dot attach and then the pin number, pin 3. So I have servo1 dot attach pin 3. Now we mentioned this a little bit ago, but if you want to control a servo using the Arduino, you've got to use pins 3, 5, 6, 9, 10, or 11. And in some cases you need those higher level pins, the 11, 12, 13 for our communication. Luckily, if you're using I2C, some like I2C sensor, that's using a 4 and 5, so that gets out of the way. But there are those options, so 3, 5, 6, 9, 10, and 11. Okay, the first thing we're gonna do, it's gonna be crazy. All we're gonna do is we're going to tell it to go to 0 degrees. Oh my gosh, so crazy. Just kidding. Okay, so we're telling this to go to 0 degrees. That being said, if we send our servo to 0 degrees and it was already at 0 degrees, there's no way for us to tell if it's actually working. And so we're gonna get a little bit crazier here. We're gonna go ahead and we'll say for half a second, then we want you to go to 180 degrees, stay there for half a second. And so now this is super simple. All we've done is we have imported the servo library. We've named our servo. We've told it to attach to pin 3. We've told it to go to 0 degrees for half a second, then go to 180 degrees for half a second. Okay, so let's go ahead and we will plug this guy in, upload this code, and see the result. Sure enough, our servo is moving from 0 to 180 degrees, albeit a little bit frantically here. So whenever we're talking about servo control, we often want way more control than just going to 0 and 180 degrees. And so let's go ahead and take a look back at the code to see if we can't add a little bit more control. All right, so getting that basic servo movement is not very hard, right? So we name our servo, we tell the servo which pin to go to, we say what degrees that we want that servo to be at and for how long. We've got it taken care of. That being said, you often want way more control than just your servo going to a specific degree. And so there are a few different ways to do that. There are actually some great built-in examples in the servo library. So if you go over to examples servo, there's knob and sweep. So sweep uses a for loop to move a servo backwards and forwards over and over again. And that's really great if you're unfamiliar with for loops and how those function. We also have the knob example, and that takes a potentiometer reading, right? It's from a like a potentiometer for a guitar, or smaller potentiometers for breadboards, or even like a joystick, and correlates that movement with the map command. And that's also really, really awesome. But in this example, I'm going to show you a super easy way to get a lot more control using position variables. So we're using the ACBR robotic laser cannon as an example. I'm going to go ahead and share the whole schematic for this project on the website. So there's always a tutorial on our website that goes along with these videos where we can go in a little bit further depth and show pictures and stuff like that. So if you're curious about what this actual schematic looks like, say you want to build this on a breadboard, head over to the website because we've got that information there. But in this case, I need a few more variables. And so I'm going to go ahead and make a position X variable and a joystick X variable. You can name these variables wherever you want, right? Does not really matter. Let's see, actually I'm gonna go ahead and give this a value. I'm gonna say position X equals 90 because we want our servo to start off at 90 degrees. Okay. So in the void setup, we can do something actually pretty tricky here. We can make sure that our servo always starts at 90 degrees. So in the void setup, right, because that runs once at the start of the program, we're still using pin 3. We say the very first thing I want you to do is go to position X. Okay, now our void loop here is going to look a lot different. So we created two new variables. We had position X and we had joy X. And so in this case, I'm going to first give joy X a value. So I'm going to say joy X equals analog read A0. And A0 is the pin that I have hardwired into the circuit board. But again, check out the schematic that we have on the website if you want to see this, where this would actually be wired up on an Arduino if you're using a breadboard. Okay, so how joysticks work, it's actually really, really cool. So all a joystick is doing is it's taking in voltage, in most cases 5 volts. And as you move the joystick forward and backward, left and right, all you're doing is changing the voltage using potentiometers. So in reality, there's two potentiometers in there, one for X and one for Y, or one for forward and forward, backward, one for left and right. And as you move the joystick, you're changing the voltage, making it go up or down. And so what's cool is if we use the analog read command on the pin that we've plugged into our joystick, we can read that change in voltage as a numeric value. And if we were to just run this, you'd see that you see the numbers 0 to 1023 whenever you're in the serial monitor. And so we can actually use those numbers that we get from the joystick to move our servo. Okay, so I have a value. I say joy X is whatever voltage I read on pin A0. Okay, so we are going to need a conditional statement here. So I'm going to say if that value goes greater than 800, then I want my servo to go to position X. Else if joy X is less than 200, I want my servo to go to position X. Now, if we uploaded this code right here, absolutely nothing would happen. Because we've said go to the same position under two different conditions. But what we want to do is we want to move our servo based on that joystick position. And so I said a few minutes ago that as you move the joystick, if you were to open up the serial monitor, you'd see the numbers 0 to 1023. So 1023 would be if you held the joystick in one extreme and 0 in the other. And so if I make a condition based on the number 800, then I know that that joystick must be close to one of the extremes, because you get right about 500 or so in the middle. And so if I move the joystick to one extreme, move my servo, again with 500 being in the middle, if that value goes less than 200, I want you to also do something with the servo. Except in this case, it's not going to move until we change the value of that position variable. And so in this case, I'm going to use a little bit of shorthand using plus plus and minus minus. Now, if you're familiar with programming in general, this is going to be super familiar to you. But if you've seen this for the first time, it can be kind of confusing. And so all plus plus is shorthand for add 1. So add 1 to the value of position X. Minus minus, it's just the same. It's take away 1 or subtract 1. And so now what's going to happen is that as I move my joystick forward and backward, I'm going to increase and decrease the value of my position variable. And as that value changes, my servos will respond in kind. Now, in reality, this is going to move way too fast. So I usually put a little delay in there. Let's say we'll do 20 milliseconds. One thing that's really cool too is if you're writing this code here and you want your servos to move faster, all you need to do is make this number smaller. Okay, so I am now reading some voltage here, and I am moving my servo forward and backward based on that there. Okay, so here's what we're gonna do. We're gonna go ahead and upload this code again, and then we will see if we can tell the difference. And so, sure enough, as we move the joystick left and right, we have our servo moving left and right. So for more information on the actual laser cannon itself, head to our website. We have tons of stuff all about how to program that on there. Also, we have some more videos here on our YouTube channel. But before we move on to how to do this exact same thing with ESP32, I want to show you one more thing. This isn't exactly necessary, but it's always a really good idea to add. Let's head back over the code really quick. And so, as we saw in that last example, we had nice, steady control, right? So we had the voltage we were reading from the joystick, we moved the servo backwards and forwards, and that worked really, really well. But there's one more thing that I always recommend adding, which is not necessary, but I think it's a really good idea. So we talked about how all this part of the code here is doing is making the position variable smaller or larger. Now here's the thing, if you move this joystick forward, right, position variable here is getting smaller. So it starts at 90 and then it goes to 90, 80, 70, 60, 50, all the way down. But if you keep holding that joystick down, that number is gonna keep counting. And so it counts all the way to negative. And so obviously the servo can't go to negative 60 degrees, right? And so the exact same thing can happen on the positive side. So the joystick variable goes forward, that variable just gets bigger and bigger and bigger and bigger, and it'll go past 180. So it goes to 180, 190, 200, and the servo just won't move. And so what can happen is if you keep holding the joystick down, it'll seem like the servo is not responding anymore. But the problem is your range is totally out of whack. And so luckily, there's actually a really easy solution. So we're gonna add in a second condition. All I've added is, I've said, hey, if the joystick value goes greater than 800 and the position value is greater than 0, then take away from the position variable. So this will make sure that we never go past 0. Now down here, I'm gonna add in the exact same condition with a little bit of a twist here. If position X is less than 180, because the servo can't move past 180. And so I've said that, hey, so long as position X is still less than 180, go ahead and add to the value of position X. And so if you were to upload this here, you would see that you could hold the joystick down for as long as you want and the servo would never try to go out of its normal range. And again, that's not necessary, but I thought I would add that just in case people were curious about the best possible way to use the position variable to control the servo. Okay, so we've got the Arduino side down. Let's head back over to our ESP32 so we can talk a little bit more about that. All right, so in order to demonstrate how this works for the ESP32, I thought I would bust out our brand new ESP32 robotic arm driver board. I am so pumped about this new board. We actually have this as a kit available up in the shop, and right now I have one of our Mi arms plugged in. We've got this in the shop too. Now it is a great little robotic arm. But it's going to be perfect for showing us the differences between using servos with the Arduino and servos with the ESP32. Because if you look closely, we're actually using the exact same servos for this robotic arm. But one thing that's really cool about this driver board here is that we also have the hole patterns, you can kind of see it right here, for the much larger all-metal robotic arm that we use on the Voyager and Explorer robot. So the code that you learn for this small robotic arm will actually be the exact same code if you wanted to use this for the Voyager or Explorer or put that other larger robotic arm on there. So let's go ahead and take a look at the code, so that way we can talk about the differences between how you program the servo for the Arduino versus the ESP32. All right, let's take a closer look at what it takes to do the exact same thing that we just did with the Arduino with the ESP32. So there are definitely a couple of differences here. But after we break down all the code, you'll see that in reality, we're using different numbers, but there's really only one extra step. And that's this guy right here. But before we get to that, let's talk about the Arduino file. The library file. We do need a library file just like before. Now the name is not as simple as servo.h. That being said, it's not that much harder to type in this other library file. So one thing I'll mention though, there is an ESP32 servo library. It's an unofficial library that somebody else created that is really, really good. And it functions the exact same way as the Arduino library. That being said, you don't have quite as much control over your servo and the PWM channel that you're creating. And so I highly recommend that you try this method first. Definitely go download that library, see how it works. There's also some great example code in that library. But that's not the method we're going to show right here. I want to show you guys how I would recommend doing it. And it's a little bit more complicated, but you have a lot more control. So all you have to do here is grab this library file. And this is included in the ESP32 board files. So whenever you load the ESP32 into Arduino, you have this library built in. And so this LEDC, that's referring to the LED channel. And that's kind of misleading. Really all we're doing is creating a PWM channel. But that's what that C reference is there. Okay, so this first line of code right here, this is where it starts to be a little bit weird here. So we have LEDC setup. And so what this is doing is this is setting up our PWM channel. So there's that C for channel. And so what this means is we're using we're setting up channel 1. We're going to use a frequency of 50 hertz and we're going to use 16-bit resolution. Now, if you don't know what the frequency and the resolution has to do with all of this, don't worry about that. I highly recommend researching it further because it is super, super interesting. The most important thing to take away from this is that this is the line of code that we need to set up channel 1. 50 hertz is the frequency that we're going to be using for our PWM signal, and 16-bit resolution. So whenever you're using a command in Arduino, like analog write 255, you're using 8-bit resolution. And so that's actually one of the cool things about the ESP32 is it allows you to use a higher resolution for your PWM signals. Now for smaller servos, that's not really necessary, but you can do some crazy stuff with that, and it's really, really cool. So this is the line of code that we need to set up our PWM channel number 1. Okay, now this next line of code is actually really similar to what we had in the void setup on our last bit of code. We are attaching a pin to that PWM channel. So in this case, we are attaching pin number 23 to channel 1, the channel that we just set up. So instead of just name.attach, we have LEDC or LED channel attach pin 23. So it is written differently, but saying pretty much the exact same thing. Okay, now if we want our servo to move, what we need to do is we need to tell that channel how many microseconds we want our PWM signal to be. Now in this case, 1638 is not as simple as just saying 0. I totally get that. That being said, once you know that 0 is the same thing as 1638 for this servo, you can repeat that over and over and over again. So in this case, I'm telling channel 1 to create a PWM signal at 1638 microseconds. Now down here, I have channel 1 sending out 7,864 microsecond PWM signal. And so that is the exact same thing as saying 180 degrees. Now for these micro servos, they actually go a little bit further than 180 degrees. And that's actually one of the cool things about using this method here is that you have way more control. So if your servo actually goes over 180 degrees, you have that range to use that full range of motion. So let's say you wanted to go a little bit smaller or your servo is a little bit different. You can absolutely play around with these numbers a little bit. So you could 7,400 as your maximum. Or you could use the numbers that we use here, right? So you could also try, instead of like 1600 here, try 2000 and see what happens. So the numbers that I'm putting in here are directly correlational to the amount of degrees. It just happens that this number right here was perfect for us for 0 degrees, and this number right here was perfect for us for 180 degrees. And more than likely, those numbers are going to work pretty well for you guys too, no matter what server you're using. Now, that being said, you may have to change them a little bit, but it's super, super easy to play around with. So the code isn't that much longer. In reality, we only have one extra line of code, and that's setting up that channel. Let's go ahead and we'll upload this code here to our ESP32 and see what happens. Once we have our code uploaded, sure enough, we see that the servo is moving from roughly 0 to 180 degrees, just like we had before. So in this case, like I said, feel free to mess with those numbers a little bit. So say you want it to go a little bit further in, not be quite so wide in either direction, you can absolutely do that. But you see that the differences between the two codes is not all that crazy. So just like before, we don't want to just have our servo moving by itself. We want to have control over it. And so what we're going to do is, instead of using an onboard joystick, since this guy doesn't have one, we're going to use the PS3 controller, because that's a really great way to get joystick data wirelessly and use that data to control our ESP32 and our servos. So I actually have a whole guide on doing exactly this in another video. And so if you're interested in that, go through that video, it's awesome. But I'm also gonna show that here just so you guys see those differences in that code. Let's head back over to Arduino so we can see that difference. All right, so let's take a look at what it takes to get that same level of control that we had before, except this time wirelessly, because we're using a PS3 controller, but using that position variable to move our servo backwards and forwards. So now this example code does have a lot of extra stuff just for that PS3 controller. I'm not gonna go into too much detail on that. Again, I have other more in-depth tutorials on our YouTube channel and our website that go into that. But the most important thing I want you guys to see is using those position variables. So if you look here at our main conditional statements, so I'm getting the PS3 controller data, I'm using one of the joystick data channels, RX, the right joystick on the x-axis. And I have different numbers here in terms of what I receive from the controller. So in this case, instead of 800 and 200 being the joystick values, I'm using -5 and 5. And obviously, instead of 180 and 0, I'm using 8,000 and 1,500. Because if you remember, our minimums and maximums, one was around 1,600, the other was around 7,800. This is doing the exact same thing. So this is just more of a generalization, but I'm doing the same thing. So if my right joystick goes less than -5, therefore moving in one direction, add 25 degrees to the value of position 1. If my joystick moves in the opposite direction, then take away 25 from that. Now in this case, we're not using plus and minus because we're dealing with a way wider set of numbers, you know, from 8,000 to 1,500. And so if you used just plus or minus, your servos would move incredibly slow. So the only difference here is the numbers we're using, but the concept is the exact same. We have our same channel setup, right? We're still using pin 23. In this case, our position variable, we're using 5,000 because that's right around in the middle. If you remember in our last code for the Arduino, we used 90 because 90 degrees is exactly in between 0 and 180. Other than that, with the addition of the PS3 controller code, this is the exact same. So let's go ahead and upload this here, and then we'll see what happens. So sure enough, if we turn on our robotic arm here and we hold down that middle button to pair the PS3 controller, once it is paired, you'll see that I have that exact same control. And so we've made a couple of steps from that first Arduino code, right? So in the Arduino code, we use the onboard joystick to control servo backwards and forwards. And so here we have a wireless joystick doing the exact same thing. Now, admittedly, the code is a little bit more complicated, but if you break it down, it's pretty similar. So I hope that was helpful, guys. I'm planning on having a lot more content for this ESP32 robotic arm driver board down the road, maybe even an ESP Now controller, a Wi-Fi controller sketch. Who knows? There's so many options here, but I hope you enjoyed this tutorial all about the differences between controlling servos using the ESP32 and the Arduino. They are both awesome platforms and both great for creating robots. For more tutorials, head over to our tutorials page on our website. We also have tons of really fun stuff here on YouTube, so check it out. Have a great day, guys.